Hello. Hello and welcome to this video. In this video, we will solve 27th set of problem of quadratic equations and polynomials. That is question number 261 to 270, and we will also look at question number 255 for which the calculation was wrong. So before that, I will show you how to download the PDF. You can go to my website ashtabakra.org or www.ashtabakra.org and you click this second link. When you click this second link, this file will open. You can click save here to download it. Okay, don't worry about this link. I will give it in the description in any case. Okay, so with that out, let's go on to our questions. Sorry. So first we will deal with question 255. So question 255 stated that for what values of a will the roots of the equation 3x square plus 7 plus a into x plus 8 minus a is equal to 0 will be equal. So the calculation was that this 96 was missing from the calculation, and therefore this will become minus 47a, and the answer remains the same. So with that out, let's move on to our questions, that is 261 onwards. So as always, I'll say that when I'm stating the problem, you should pause the video, and only if you cannot solve the problem, you look at the solution. So with that out, without further ado, let's get started. Question 261 says that show that the roots of the equation x square plus rx plus s is equal to 0 will be rational if r is equal to k plus s by k, where r is k are rational. So we are given that r is equal to k plus s by k, that is r square is equal to k square plus s square by k square plus 2s. Now what we do is we subtract 4s from both sides, so it becomes r square minus 4s is equal to k square plus s square by k square plus 2s minus 4s. This should be, there is an extra character here. It's a typo. R minus 4s is equal to k minus s by k whole square. Now if you see this should be r square minus 4s. Now if you see this, r square minus 4 is greater than or equal to 0. If r is k are rational, which is discriminant of the given equation. Now if you look at this equation, the discriminant is r square minus 4s, which is 0. So the roots will be rational, provided this given condition is met. Question 262 says that prove that roots of the equation x minus a into x minus b plus x minus b into x minus c plus x minus c into x minus a is equal to 0 are always real and cannot be equal unless a is equal to b is equal to c. So we write the equation in its full form. We get the equation as 3x square minus a plus b plus b plus c plus c plus a into x plus ab plus bc plus ca is equal to 0. So this is 2 into a plus b plus c. So discriminant would be 4 into a plus b plus c whole square minus 12ab plus bc plus ca. Now we expand this, we get 4a square plus 4b square plus 4c square minus 4ab. There will be 8ab, 8bc, 8ca coming from this, which we subtract from this. So we get minus 4ab minus 4bc minus 4ac. Now if you look at this expression, it is equal to 2 into a minus b whole square plus b minus c whole square plus c minus a whole square. Now this term cannot be 0 unless a is equal to b is equal to c, because if any two are not equal, then the square of that will be non-zero. So for the discriminant to be 0, the condition would be a is equal to b is equal to c, which is the condition for roots to be equal. Question 263 says that if a, b, c are rational, show that the roots of the equation a square into b square minus c square into x square plus b square into c square minus a square into x plus c square into a square minus b square is equal to 0 are rational. So we write the discriminant, it would be b to the power 4 into c square minus a square whole square minus 4a square c square into b square minus c square into a square minus b square. Now we expand this. So after expansion, what we will have is, if you go on and read it, you will find that it is equal to b square c square plus b square a square minus 2a square c square whole square, which will be greater than equal to 0. And also note that it is a perfect square, and thus root will be rational. Question 264 says that show that the roots of the equation a to the power 4 plus b to the power 4 into x square plus 4abc dx plus c to the power 4 plus d to the power 4 is equal to 0 cannot be different if real. So again we compute the discriminant, and we see that the discriminant is minus 4 into a square c square plus b square d square whole square into a square c square plus b square d square whole square. Now if you see this, it is a perfect square. Now this will be either negative or 0. Okay, so if the roots are real, it cannot be negative because negative will make the roots complex. But given that roots are real, so the only possibility is discriminant has to be 0. So once it is 0, the roots will be equal. So they cannot be different. Question number 265 says that if P, Q, R are in HP and P and R are of the same sign, prove that the roots of the equation px square plus 2qx plus r is equal to 0 will be complex. Now the discriminant of the given equation is 4q square minus 4pr. So 2q square, 4q square minus 4pr. So that we can write is 4 into p square minus pr. Now it is given that PQR are in HP. So Q would be 2PR by P plus R. We plug in the value of Q in this, we get 4 into 4P square by P plus R whole square minus PR. We expand this and eventually we arrive at the equation 4 into minus PR into P minus R whole square by P plus R whole square. Now given that PR have the same sign, P and R have the same sign, so PR would be positive always, and P minus R whole square will be greater than equal to 0, P plus R square will be greater than equal to 0. Therefore, the overall sign of the discriminant is negative, and therefore roots will be complex numbers. Question 266 says that prove that the roots of the equation bx square plus b minus c into x plus b minus c minus a is equal to 0 are real if those of the equation x square plus b 2bx plus b is equal to 0 are imaginary and vice versa. So the discriminant of the first equation, if we expand it, it becomes b minus c whole square minus 4b into b minus c minus a, which is b square plus c square minus 2bc minus 4b square plus 4bc plus 4ab. Now the discriminant of the second equation is 4b square minus ab. Now if d2 is less than 0, okay, then 4b square minus 4ab would be less than 0. So the discriminant 1, if you look at it, this is minus 2bc and this is 4bc, okay, so that will be 2bc. So we can write this as b plus c whole square, and this term 4b square and 4ab we can write as 4b square minus 4ab. Now this is our d2 here, okay, which is less than 0, and now we have a negative sign, so this would be positive. Therefore roots would be real. However, if d1 is less than 0, that is roots are imaginary, then what we have is b plus c whole square minus 4b square minus 4ab less than 0. That implies that 4b square minus 4ab is greater than 0. Therefore, the roots of the equation will, the second equation will be real. Question 267 says that prove that the value of the x obtained from the equation ax square plus by square plus ax square plus by square is equal to 1 and ax plus by is equal to 1 will be equal if a plus b is equal to 1. So from the first equation we get x is equal to square root of 1 minus by square by a. From the second equation we get x is equal to 1 minus by a. So we square this and we square this. We get 1 minus by a whole square is equal to 1 minus by square by a. And we write it. So this a will cancel this a and a will be multiplied with this a. So 1 minus by whole square would be 1 plus b square y square minus 2by, and a when multiplied with this would be a minus aby square, and we can rewrite this as b square plus aby square minus 2by plus 1 minus a is equal to 0. Now values of x will be equal if values of y are equal. That is, discriminant of the above equation is 0. So if y has a single value, that is the two value obtained from this quadratic equation are equal, then there will be only one value of y giving us one value of x. And therefore we compute the discriminant of this. Now this is 2by, so it would be 4b square. There's a mistake, it shouldn't be 42. 4b square minus 4 into b square plus ab into 1 minus a. And we expand this, we get 4b square minus 4b square plus 4b square a minus 4ab plus 4a square b. And 4b square and 4b square will get cancelled. We have a square b plus ab square minus ab is equal to 0. We take out ab, and once we take out ab, we will get a plus b minus 1 is equal to 0. Okay, so that implies that either AB is 0 or A plus B is equal to 1. There is typing mistake over here. Question 267, I note it. I'll fix it. So question 267 and the other one was this one, 261. 261 and 267 have typing mistakes. Now we move on to question 268. Prove that the values of x obtained from the equation x square plus y square is equal to a square and y is equal to mx plus c will be equal if c square is equal to a square into 1 plus m square. So proceeding like question 261, we have y is equal to mx plus c. So we put this value in the second equation. We get x square plus m square x square plus 2cmx plus c square minus a square is equal to 0. And for roots to be equal, discriminant must be 0. So we get 4c square m square minus 4 into 1 plus m square into c square minus a square is equal to 0. So we simplify and we get c square is equal to a square into 1 plus m square. Question 269 says that the roots of the equation 4x square minus 5a plus 1 into x plus 5a is equal to 0 are alpha and beta. If beta is equal to 1 plus alpha, calculate the possible values of a, alpha and beta. So here sum of roots would be 5a plus 1 by 4, and roots we have taken as alpha and alpha plus 1. So 2 alpha plus 1 is 5a plus 1 by 4, and alpha is equal to 5a minus 3 by 8. Now products of root would be alpha into alpha plus 1 is equal to 5a by 4. Now we substitute the value of alpha from this equation over here. So we get 5a minus 3 by 8 whole square plus 5a minus 3 by 8 is equal to 5a by 4. Now we simplify this. We arrive at the equation 5a square minus 14a minus 3 is equal to 0. So a is equal to 3 and minus 1 by 5. Now if a is equal to 3, alpha is equal to 3 by 2. If a is equal to minus 1 by 5, alpha is minus half. Once we have alpha, we add it to 1 to get the value of beta. So that is trivial. Now we solve question number 270. If one root of the equation 5x square plus 13x plus k is equal to 0 be reciprocal of another, find k. So in this case, we let the roots be alpha and 1 by alpha. Now clearly product of roots will be alpha into 1 by alpha is equal to 1 is equal to k by 5, which implies that k is equal to 5. So with this, we come to the end of 27th set of problems in this chapter. and there are lots of problems. We are roughly halfway through it. There are 548 problems in this chapter. So stay tuned for those videos. I mean, it is insane number of questions that there are in this chapter. So I hope that you are finding this series of videos useful and informative, and it is helping you with your studies to clarify the concepts and getting practice done. So I'll say what every YouTuber says, that please subscribe to the channel, like the video, share it on social media, share it with your friends and families. And if you have questions or you want to correct any mistakes which I have made, make use of the comment box. And also, if you need videos on any other topic, let me know in the comment box. By the way, for your information, I will tell you something, which is that what is going on. So if you go to astavak.org, what happens is, right now I'm working on trigonometry. Okay. So if you look at this book, it will download in a second. So if you look at this book, what is going on is, if you look at these chapters, then you will see that it is summation of trigonometric series. But I have moved on and I'm working on De Moivre's theorem. Okay, there is a 16th chapter. So 15 chapters are complete. You can read it very well. You can read it. De Moivre's theorem will be complete in probably 3-4 days, and then there will be miscellaneous chapter. Once this book is complete, I will work on another book, gitlab.com/. So I'm just letting you know what is coming up. Shivshankar.dayal. So once this is wrong URL. Okay. So there is a book I'm supposed to write, which is on Git. This book is to be written in Tipst or Typist, however you pronounce it. It won't be in contact. So along with this, there will be another book for coordinate geometry. So what is of possibly your interest is the coordinate geometry book. So after trigonometry, there will be a coordinate geometry book. So if you look at repositories, I already set this up. So this is what will be coming, and these books will come much faster because Tipst or Typist processes the books very fast compared to Contact. So a lot less time will be required to write these books. Okay. So stay tuned for this, and thanks a lot for watching the videos. Enjoy.